Welcome to Week 3 Operating System. This is Dr. Eliza. In this week, we are going to learn about process states, process creation, inter-process communication. First, what is process? Process is a program in execution. The execution of a process in a sequential fashion. A program is a passive entity, while process is an active entity. A program is a set of instructions which are executed when a certain task is allowed to complete the task. The programs are usually written in programming language like C, C++, Python, Java, and so on. What's the difference between process and program? When a program is loaded into memory, it is divided into 4 components: stack, heap, text, and data. What is stack? The process stack stores temporary information such as method or function arguments, the return address, and the local variables. Heap. This is a memory where a process is dynamically allocated while it is running. Text. This includes the current activity represented by the value of a program counter, and content of the process registers. Data. This section contains the global and static variables. What's the difference between process and program? Process is actively running software or a computer code. A program in execution is called a process. Program is a set of instructions which are executed when certain task is allowed to complete the task. Process is dynamic in nature, whereas program is static in nature. Process is active in nature, whereas program is passive. Process is created during the execution and it is loaded directly into the memory, whereas program is already existed in the memory and it is present in the secondary memory. Process has its own control system known as PCB, process control block, whereas program does not have any control system. Process changes from time to time by itself. Program cannot change its own. A process needs extra data in addition to the program needed for management and execution. Program is basically divided into 2 parts. One is code part and another part is data part. Process have significant resource demands. They require resources like memory, CPU, input, output until their existence in the OS. Program just needs memory space to store its instruction. No further resources are needed. PCB, process control block. This is a part of OS, aids in managing how process operate. Every OS process has its own PCB. A PCB consists of process ID, state, pointer, priority, program counter, CPU registers, IO informations, accounting informations, memory management informations, and so on. What is process state? A process at a particular time is called a process state. When a process executes, it changes from one state to another state. Process state may differ in different operating systems and the names of the states also not standardized. A process can be in any of the following states during their lifetime. Process may be running, new, waiting, ready, or terminated. Two-state process model. In this, there are only 2 states. The state 1 is running, the state 2 is not running. When the process is running, it will be in running state. Once the process completes its operation, it will exit. So the process, when it is passed, it will be moved from running to not running. When the process is dispatched to CPU, it will be moved from not running to running. 5-state process model. In this, we have 5 states. A process may have 5 states. State 1, the process is in new. State 2, once the process is admitted into the CPU, it will be changed as ready to execute by the CPU. The readily available process in CPU will be dispatched to CPU and it will be changed as running. When the process is running in the CPU, if it needs some input-output operations, then the process will move from running state to waiting state for IO operations. when the process is finished its IO operation, it will be moved from waiting state to running ready state again. Okay, so once it is ready to execute, it will again move to CPU in running state. Suppose when the process is running, it may be interrupted by software or hardware. So that time the process will be moved from interrupt to ready, running to ready by interrupt. Okay, so when the process is running, once it completes its operation, it will be moved from running state to terminate state. So new, ready, running, terminate, or it will enter from new to ready, ready to running, running to waiting, waiting to ready, or ready to running, and so on. So this is whatever I explained the previous slide, that only given explanation here, 5-state process model. So I am moving to the next one. There is one more state model called a 7-state process model. Additionally, 2 more states. I don't want to explain again for the 5 states. What is the 6th and 7th state? The 6th and 7th states are suspend wait and suspend ready. The process which is ready, which is waiting for input out operations, may be suspended. So once, sometimes after suspended, it may be resumed back to wait state. Similarly, the process ready to run may be suspended into another state called suspend ready. The suspended ready state process may move to ready state later. So the suspend wait, from wait to suspend, suspend to wait, suspend ready, ready to suspend, suspend to ready. So these are the additional 2 states in 7-state process model. This only explained here in this slide, so I don't want to repeat it again. 7-state process model: suspend ready, suspend wait. Verify your learnings. When the running process need to do IO operation, the process will be moved to which state? Waiting state. Answer is C, waiting state. Question number 2. A process move from ready state to which state if a process with higher priority has to execute it by the main memory to be executed, but the main memory is full. So in this case, from ready state to what state? The process may be moved to ready state to suspend ready, because there is no space in the memory. So for the higher priority process to execute, it will move from ready to suspend ready. Now we'll discuss about process creation. What is process creation? Process will be created by fork system call. So when the process is created, there will be 2 processes. So the process fork system call duplicates a parent process, and the newly created process will be called as child process. So in memory there will be 2 processes. So the memory space for parent process is independent of child process. So fork is creating a process. So how we create a process? When a new process is created, OS assigns a separate process identifier, separate memory space, separate PCB, process control block. Everything will be new for the newly created child process. So that is the meaning of fork. So here you see the diagram. Main program, forking creates a child process. Now we have 2 processes, parent and child. This is syntax of fork. Fork, there is no arguments. The fork system call creates a process, and the fork system call returns 2 value. Not returns only 1 value in 2 location. The fork system call returns 0 in child process. The fork system call returns the child ID in parent process. What do you mean by wait? So when a process is created newly, the child process execute first, but it is not all the time. Most of the time child process will execute. Suppose if you want to make parent process to wait for the child process, we use this wait system call. Okay. This is syntax of wait. Wait. Don't misunderstand about or don't confuse about this data type. This is a system data type PID underscore T. Mostly it will be a long integer or integer. Wait system call has only one argument, optional argument, that is stat location. So when we make a parent process wait for the child status or the child status will be stored here. So if you have only one child, then the parent will be wait for that particular child. If you have more than one child, then the wait argument will mention the address of the child process for which the parent process has to wait. This is a syntax of exit followed by exit code. So process may request their own termination by executing exit by itself. Verify your learnings. What will be the return value of fork in parent process? The fork returns 0 in child, and what it returns to parent? It returns a child process. So answer is D, child process ID. Question number 2. Which system call makes the parent process to wait for a child to terminate? Fork, wait, exit, or child? The command is wait. System call is wait. Wait make the parent process wait for the child. Now we'll study about inter-process communication tools. Inter-process is a tool which makes more than one process to communicate. There are many inter-process communication tools we have, because after a process is created, there is no relationship or there is no communication between the parent and child. Unless we make it communicate, there is no communication. So what is the advantage of IPC? Make two processes communicate among themselves, make two processes share memory, make two processes understand themselves, make two processes share some data, and so on. There are different IPC tools available in the operating system. Pipe is an IPC, shared memory, message queue, semaphore, shared memory, and so on. Different approaches are available for IPC. What is thread? We will come back to IPC after understand about thread. Thread is a lightweight process. We call it as a lightweight process. Thread of execution or thread of control, we call it as. Thread execution is possible within OS process. A process can have several threads. A distinct program counter, stack activation records, as well as control blocks are used by each thread of same process. Thread is also called lightweight process. So here we have 3 threads of one process. Thread 1, thread 2, thread 3. Each and every thread has own program counter, own stack, and so on. There are 2 types of thread: user level thread, kernel level thread. What is user level thread? There are threads. User level threads is type of thread that is not created using system calls. The kernel has no work with the user level threads. User level thread can easily implemented by users. Whereas kernel level threads are recognize the operating system easily. Kernel level threads has its own thread table where it keeps a track of systems. So see, there is 2 places. The kernel level thread is inside the kernel. Operating system kernel helps in managing the threads. Kernel threads have somehow longer context switch time. Kernel helps in the management of threads. What is the difference between process and thread? As I told earlier, thread is lightweight process. In a process, we can have multiple threads. Threads within the same process run in the shared memory space, while process run in a separate memory space. Process has separate memory space, whereas thread has common memory spaces. Threads are not independent of one another like processes. Threads share with each threads their code sections, data section, and OS resources. Like a process, thread has its own program counter, register set, and stack space. Multi-threading. The idea to achieve parallelism by dividing a process into multiple threads. That is a multi-threading. Here you see we have one thread, we have one process, multiple threads, we have two process, single threads. We have multiple process, multiple threads. These are various multi-threading types. What's the benefits of threads? Enhanced throughput of the system, effective utilization of multiprocessor, faster context switch compared to process, fast responsiveness because of fast context switch, simple communication between threads, resource shared between threads within a process. Now we will come back to inter-process communication tool. The first IPC tool is pipe. Pipe is a connection between two processes. You see here, one process write into the pipe, another process read from the pipe. This is syntax of pipe. It's an integer array of size 2. One index is used to read the pipe, another end to write the pipe. So pipe has two ends, one is for read pipe, another one is write pipe. Now see this example here. We create the pipe using pipe system call. We write content into pipe P of one end, and we read from another end. That's a simple example. Parent and child sharing a pipe. So how communication happens? Parent process writes something into the pipe. The same thing will be read by the child process, and so on, vice versa. So this is the way the parent and child are communicate among themselves using pipe. So this is an example how I write a program to read a messages through pipe using a parent and child process. So same thing, whatever I explained earlier, the same thing is here. You see we create a process. One process write into the pipe using P1, one end of the pipe. The other process, parent process read using P of 0, that is another end. So child process write into P of 1, parent process read from P of 0, that is read end. This is the way. Verify your learnings. A pipe has how many file descriptor? The pipe has only exactly two file descriptor, P of 0 and P of 1. One is for read and another one is for write. The pipe will exist in the system call until process terminated. Once the process terminated, pipe will be elapsed. Named pipe is called a FIFO. This is very similar to pipe, but here we can store using a file name. For example, here you see MK node, MK before, MK node, or the way to create the pipe. So here we have three arguments. The first argument is the name of the file. So using the name of the file, we can store the pipe, that is FIFO. So here we have a mode. The second argument is mode. These are different modes. In which mode we open a file. Either if you open the file, FIFO file, character special file, these are different types of files. So the file types will be used in the mode. Creation of named pipe using MK-FIFO. This is another way to create named pipe, MK-FIFO. First argument is pipe, path name, that is name of the pipe. Second argument is mode. FIFO example. So it's similar to pipe. Here we see we create a FIFO using FIF1 name, and using a write statement we write into the pipe. The child process write into the FIFO. The parent process read from the FIFO. What is the name of the named pipe? The answer is FIFO. Which of the following system used to create a named pipe? Among these, the answer is MK-FIFO. To create a named FIFO, we use MK-FIFO. What is the message queue? The next inter-process communication tool is message queue. Message queue is an inter-process communication tool. Similar to pipe, here one process send a message to another process through message queue. So these are the system calls used to message queue in system 5. System call. MSG get is used to create a message queue, and MSG send is to you to send a message queue. MSG receive is received a message queue. MSG control is to perform the operations on a message queue. This is syntax of MSG message queue creation. MSG get is to create a message queue. MSG send is to send a message to the message queue. MSG receive is to receive the message from the message queue. And this is the program example for message queue. See here, we create a message queue using MSG get. We send a message. This is a sending program. And receiving program, you see, we create a message queue. We receive the message using MSG receive. Which system call is used to send a message to the message queue? MSG SND. MSG SND, the last one. Which of the system call is used to create a message queue? MSG get. The C. Answer is C, MSG get. Shared memory is another inter-process communication tool. So using shared memory, two processes shared among themselves. So how one process send two processes shared with each other using an address, and using that address they are shared. So SHM get is used to SHM get is used to create a shared memory. Attach a shared memory. A process will be attached with the shared memory. This is to detach from the shared memory. This is an example here. You see, we create a shared memory using SHM get. We are writing into the shared memory. It means we are one process write into the shared memory. Another process will be read from the shared memory. Which system call is used to create a shared memory? SHM get. Answer C. Sorry, D. SHM get. Which system call is used to delete a shared memory? SHM detach. Answer A. So in this week we learned about process, process states, process creation and various inter-process communication tools. Thank you.